Thanks everyone. Thanks for coming. And kind of feel a little shy actually. I didn't want to do a big introduction, but I do have a slide. So, all right. So welcome to this talk. And first, I wanted to see. You guys probably saw on the agenda we have 2 full hours of containers. Yay! No? Well, don't worry. So Josh and I synced up ahead of time, so we know who's going to talk about what. So you're going to get really good material for the 2 hours if you wish to stay for 2 hours. Let me start with who I am, and I'm currently Director of Solutions Engineering at Eclypsium, which does hardware and firmware security. I did a stint as a security architect for Checkmarx, and people probably heard of Checkmarx, focusing on application security. And then before that, I was leading a group of professional services for identity and access management. So I've literally been up and down the security stack. And over the years, I got a lot of certs and everything, and just a lot of experience in being the higher side of the stack. So what this talk is not going to be about, I'm not here to talk about Docker. Well, actually, I'm probably not kidding anyone. You cannot not talk about Docker. I am going to be talking about Docker, but not just about Docker. So what I'm also not going to be talking about here in this presentation is everything that's low on the stack. So I work in hardware and firmware security, and I work with those exploits, but a majority of my experience is actually dealing with an enterprise level security, as you've seen. So it's everything up above the hypervisor stack, it's in the kernel stack, it's the user space stack. Everything else you see down below, I hope everybody understands. If you get owned by one of those things, you're screwed anyhow, right? You're really, there's no talk about containers at that point. So, but I'm not going to talk about it. I'm going to talk about containers. And when you talk about containers, and if anybody's been into presentations about container security, you know you have some obligatory slides. So here's a slide about container history, all right? I'll just move on. Okay, here's a slide about broken containers. Broken, they're horrible. Okay, here's a dead whale, okay? Dead whale for you guys. All right, good, now that's out. We can actually get to the presentation. Okay, so I wanted to share a story, and it's a story about me about a year ago or so. And this is where I've inherited what I call traditional, some people call legacy. I like to still call traditional security products. It's a monolithic product. It's focusing on enterprise level security. It's focusing on certain things that developers do, and it's trying to analyze the workflow of the developers. Now, developers are on the forefront of technology, as I'm sure everybody's noticed. They're screaming containers. They've been screaming it for 5 years, for 6 years. They've been screaming microservices for 4 years. They now are screaming serverless. Been screaming for 2 years. So it's all the cool and new technologies that are coming on the market, and they really want to try it. They want to, make an impact, build something cool, build something quick, and they are my consumers. I'm essentially working for them. I need to provide a product that lives in their ecosystem, and I'm stuck with the legacy product that lives in the ecosystem of Windows, .NET development, services, Windows services, MS SQL, and all that stuff. And I have certain goals. I need to make it secure. I need to make it fast, and I also need to make it so it fits inside of the DevOps infrastructure. So essentially, Ops is serving devs, and devs are making their crazy decisions, and Ops wants to put everything in the fast pipeline. You want to put something in where you can get a turnaround for the servers, for the devs, and now I need to make that product, the legacy product, work in that pipeline. And so I go, okay, well, let's start with this. Let's start with why containers are pretty cool, I heard. Let's start looking at what are they for. And looking at it, you realize that there's actually 2 goals, and they're not necessarily competing goals. That's something that developers need, and they're trying to close this gap, and they're closing it in 2 kind of dissimilar ways, but One and the more important one for the devs is distribution. Is how do I package it up in applications so it works smoothly in all the systems? How do I put it in my dev box and then give it to the ops guy and then he can run it with no changes? So that's the distribution problem. Now the second problem is how do I run untrusted code? And by untrusted, in the dev sense, it means somebody else's code. It's like, it's Node.js. I don't necessarily not trust it, but it's Node.js. Who knows where it can go out? So it's better if I close it. And that's the sandbox problem. Now, they're not, like I said, mutually exclusive. And this is where containers kind of come in play. All right, so back 5-7 years ago, when you talked about containers or you mentioned sandboxes, the VMs came up, right? And we've all been using VMs for a long time. VMs are actually pretty good about containerizing applications, right? Escaping from a hypervisor out to the system has been not a thing for the past 5-6 years. Is it possible? Probably. Is it likely? Very unlikely. So they've been really good at keeping the close eye on everything that happens in the user space and the kernel space and then down to the hypervisor. So they're actually pretty secure. Now, the trouble with them is they're good for security, they're not really good for distribution. If anybody tried copying 10, 15, 50 gigabyte VM off to ops machine, you know that, right? So there have been systems, there have been solutions to try to make them a little more portable to kind of we solved the sandboxing problem, now distribution, maybe we can solve it with Vagrant. If anybody tried Vagrant, you write basically your infrastructure as code, you push it out, it creates VMs. It's good, I use it, I actually daily use it. It manages the VMs all right, but it's still kind of clunky and it still takes time and it's still not very sufficient. The same thing with chefs and puppets who try to manage the infrastructure at the code level too. It works, I mean it's a good workaround, but it's really still not solving the distribution problem. And this is where we come to the kernel level containers, those things that kind of live in here, and this is where Docker is, right? So the kernel containers are the things that isolate your security at the level of the kernel, the syslevel calls. And I feel obligated to mention the ways that they're made. If you actually want to find out more about the details of what goes into making a container, go to the next talk. Josh is going to talk more about those, but I'll mention them here. So when I say kernel level containers are not first order primitives, that means that they're not things in themselves. They're sort of aggregation of other things. It's like a container is a thing that's put together very cleverly. And it's the other things that it's put together with are the capabilities, which limit the process privileges, the C groups, which limit the resource access, then the namespaces that isolate kernel functions, and then the seccomp filters that filter the syscalls into the kernel, and then finally you've got an overlay file system and an overlay network. So take all those pieces by themselves, they're not very much worth it, but combine them into something new and you get something like Rocket or Docker. And that's how containers came to be. And so there are multiple ways the containers are done. Actually, I'll start from the bottom. If anybody used Heroku, you've already used containers. You didn't even know that. Heroku were the first ones who actually created containers. Now, they're not public containers. You can't run Heroku containers on your box, but they're the ones who actually came up with that concept. And that's because they run untrusted code on their infrastructure. But later after that, and you can go back to the history slide if you really want it, but LXC containers happen, they're still a thing. LXC is what I call a hard mode container. It's like, you get all those primitives and you're the ones in charge in putting those together and you're the one who's enabling this. And then once you've put it all together, then you've got your car assembled and now you can actually run with it. And Canonical is trying to help. They're building something like LXD to manage those containers, but it's still kind of like hardcore mode containers for you. People use it, especially people in big companies that need very fine-grained control over containers. Now the Docker containers, and this is where the whole thing took off, right? These are the easy mode containers. There's the ones that you go and do, Docker run blah blah, and it's suddenly, woof, you've got your system. That's like uber cool. And as you can imagine, there's some cost to it, and we're going to come to costs of the ease of use. Now, there's Rocket containers, and I'm going to talk a little bit about the security of Rocket containers, but they were created to be securer, like better than Docker. Okay, and the other thing that I wanted to mention is when you talk about container level containers, you actually do have a really fine-grained control, and you can run, you can turn on and off features in those containers and do really cool stuff. So for example, I'll give you, hopefully you can see this. So here's a container that runs a Microsoft, by the way, I'm running Linux on here, but here's a container that runs GUI. The whole thing is inside of container. If you're not familiar, this is SQL Operations Studio that Microsoft put out for managing SQL Server. And you'll see my talk why I need to manage the SQL Server. But this is a Linux container with a GUI front to it, and it's running it. And if you actually want to look at it, give me just a second. I'll put this. Yeah. So, so that would be. So that's this guy. You see, I just forward X and then run the container and I get the X. So that's your GUI container. You're actually running stuff inside of the container, but you're interacting it on the GUI level with it. All right. So the other thing, really cool thing, is you can run, obviously, Windows tools will come to it, and you can run AI algorithms. So back at home, I actually have a little lab where I'm running NVIDIA CUDA Deep Dream network. And I create images with the Deep Dream network, and it's all running inside of a container, so I didn't install anything. And it was like really, really uber cool. I got AI on my desktop with no investment into building the crazy, Python modules and non-Python and everything that goes with it. And so that was really, really interesting. And the big point I want to make here is with all that flexibility comes responsibility. So there's a lot of things you can shoot yourself in the foot with, and we're coming to this. But before we go into containers, into kernel level containers, I did want to mention the app level containers, and those are the things that you probably seen too. So, for example, if you run a GNOME and you ever tried to install something from KDE, like the Kate the editor in KDE, and I really like it, and you do the usual. You do the usual apt install Kate, then it comes to you and says, okay, I'm going to upgrade 0 packages. I'm going to install 152 packages on your system. And do you want to continue? Yes or no? And the correct answer is no. So, obviously, Canonical and Debian and everybody recognize that little problem that it brings to you. And they tried working on it, so snaps happened. Snaps happened about 5 years ago. And what it is, and if you watch Mark Shuttleworth's presentations, he's actually really good about describing them. But he's describing them as the things that are here. They're not containers in the sense that are isolated from your system. They're containers in the sense that they're packaged up. So essentially, it's a packaged up application that has limited view into your system, but you also get a full use of that system. And so there's been a very subtle change. If you guys live on Ubuntu, you'll notice that sooner than later. If you type in a name of the tool that is not on your system, you'll get a prompt, and it'll go like, this command not found. Use apt install for that program. Now, if you do this on 1804 or 1810 Ubuntu, it comes up with this. Not for all programs, but with this. Notice a little difference. You see this sudo snap? They want you to run snap now. So what's happening behind, I don't know if it's good or bad. It's a thing now. That basically they're pushing people to using snaps more and more. And they actually have their own operating system, I'll mention at the end, the Ubuntu core, that's all about snaps. But snaps is just one thing in the canonical space. Now, and you can see it's basically a thing in the user space. It's not extending out anywhere down into the kernel or the hypervisor level. But there are things that existed for a long time, and you've probably heard about the Zen app and the Thin app and Microsoft vApps. Now, there are other packages like appimage0 install and Flatpak. Anybody who's lived in Linux probably knows those. You might not know, but each tab in your Chrome is actually a container sandbox by itself, and it's running inside of its own PID namespace, meaning that the programs within that tab can't see anything else. So it is a container. It's like a sandbox inside of Chrome. Now, they're only containers in the sense that this is a container. Is that a container? Well, yeah, but that's the app container. So, as I looked through all those different technologies in the past, and as I looked at my challenge, it was pretty easy to realize VMs were too hard in distribution. The app containers were too open, so I was left with the middle. I was left with the containers that are in the middle space. Now, I'm going to give you a little laydown. This is not me from a year ago. This is me from today. And this is like, if I knew what's happening with containers, this is what I've showed myself back here. But this is what's happening with the containers now. So to the very, let's see if you can see my mouse. Yay. So right here, you see your VM containers, right? This is the application that's running on a guest kernel that's isolated by the hypervisor from affecting anything on a host kernel. So essentially, your level of isolation is this hypervisor. That's VM. Now, the traditional kernel level containers like Docker live in this space. So you have an application, you have a bunch of controls and syscall filters that prevent you from abusing your host. And this filter is the one that's responsible for security of your containers. And then you go down to the host kernel. Now, the thing that happened probably a year ago, maybe a little more, is the Intel Clear containers or the Kata containers. So what they looked at the same problem and said, okay, VMs are too hard, syscall filters are kind of too flexible. How do we combine the best? And they came up with a mini OS special KSM kernel that is really fast booting, kind of quick to execute, KVM, QEMU combined into one package and simplified. So you run this. Essentially, it is a kind of VM container, but it is also very transparent. So you get the best of both worlds in theory. And then Google looked at the same problem. And Google said, all right, so how about we, instead of doing the hypervisor thing and the syscall thing, we actually create our own kernel. And we do it as a shim kernel. So all your calls from application go to that shim kernel. And then we filter it out. And we kind of will look like a kernel. We're not actually a kernel. But then whatever we allow, we get from host kernel. Which sounds really, really cool, right? It's like, wow, why not do that? And it's all the cool ideas. The trouble with this is they're all introduce a lot of performance downgrades. So somebody, and I have a link at the bottom, somebody did a performance analysis on all those kernels, and the Google gvisor came the worst. It's like the slower than the freaking VM. And then they looked at the Intel CC, and it was painful to do those too. And so when you actually look at the performance graph, and I don't have it here because I didn't want to copy it from the web page, but essentially it says your Docker things are the fastest, your CCs are probably the next, then the VMs, and then the Google gvisor. Now that could change in the future. So maybe at some point in time they're going to own up and really build it into something really cool, and maybe that's the next thing in containers. But so far it wasn't. And obviously a year ago it wasn't a choice for me either. So another thing that wasn't a choice for me is the scone. And the scone is the next cool thing that kind of happened. So containers that are running in the Intel SGX enclaves. And that's another idea. It's like, yay, how about we go one level down? Do people know about SGX? Oh, I see. So essentially it's a completely independent, encrypted area for code execution and for data manipulation that only the processor can access. And you can switch to that enclave and then execute your trusted code on that. So it really kind of pokes way from the application down to the hardware level and then brings it all up to the application level. So that's like, you can't get any more secure than that. And my question to you is, did you foreshadow it? Yeah. You guys, anybody see what I did there? No? All right, for those who didn't get it, foreshadow is an attack on SGX enclaves. It just came out fairly recently, and that's the thing that breaks stuff in the SGX enclaves. And plus, they're horribly slow too. Can you imagine bringing all the stuff down and then re-encrypting and bringing it all up? That somebody estimated it's like, actually the original paper that proposed the SGX enclaves and containers quoted that they were 18 times slower than a normal container. So there you go. I think it's an interesting technology to watch for, but that's probably even farther out. Okay, so at this point, a year ago, I made my pick, Docker and other containers were it. I needed to provide the flexibility. I needed to provide the performance. Docker was fitting. I need to have reasonable security, and I was planning to run trusted code. I wasn't, running our client's code on it, so I was fairly, confident that Docker will do it fairly well without resorting to VMs. And the next thing that kind of hit me was Windows. So now I have to bolt Windows on Docker. I was like, okay, well, Windows for Docker was the thing already at the time for probably 2-3 years. And I, dove deep down into the space of Windows containers trying to figure out what the hell is going on there. Well, I'll give you a quick gist. I'm not going to go into a lot of details, but there used to be a Google Docker toolbox, which was running containers inside of the VirtualBox installed on your Windows. Then Microsoft kind of owned up to the whole thing, and they said, all right, so how about we just, for Windows 10, which is probably dev machines, we can use Hyper-V to run your Docker containers. But for Windows Server, we create a Windows Server container subsystem that actually does run containers. So essentially, they did provide access to the NT kernel features from within your containers, so you don't have to have any of that stupid VM level in between, because I'm sure you understand, putting a VM in somewhere in the middle kind of negates the benefits of Docker speed, right? So the trouble is Hyper-V is exclusivistic. That means you can't run VirtualBox when you run Hyper-V, although I actually did beat it into existence, and I can show I'm running Hyper-V on a KVM in Linux inside of the VirtualBox, and it's horrible. Don't try it at home. But if you ever feel masochistic, I can give you pointers. So Windows containers, they run on Windows Server and Windows Server Core. The images, Windows images, have to start with only 2 distributions. Like, if you know Docker, you can start from scratch. You can go and build your Docker from the beginning. For Windows, you have to start either from the Nano Server, which is their version of Windows Server that can't run anything but 64-bit and only .NET Core applications. And if you don't know, .NET Core is a lighter version of .NET. It's more Linux friendly. They're actually porting .NET Core to Linux. And then the other thing is, or you can base it on Windows Server Core, which is an 11 gig base distribution, and then you run it with .NET, and you can have full .NET, and you can have 32-bit, and of course telemetry. Microsoft wants to know what you're doing. You can turn it off, but by default it's on, and you don't even know it. It's Windows. Okay, so that's how you run Windows on Docker containers inside of Windows, and then you can run Linux, but that introduces a Hyper-V VM. There's no tricks to it. You can't run Linux kernel on Windows kernel. You have to have a VM in between that does something for you. And that's their solution. So I'm not sure you can ever expect Windows to run Linux containers natively. But when you run it, just know that there's a Hyper-V VM underneath it. And I'm going to talk about it in a second too. So, and then when you run Windows containers on Linux, you can actually do this. And I'll show it to you. So just a second. Hopefully you can hear me still. So I'm going to switch to another shell, and this is my Docker. That's I can't type. So look at those 2 things. So this is the client, and the client is Linux, and then this is the server, and the server is Windows. So if I do Docker image, not that. Images. I have a list of images, and you see, woo, I can run Windows Server Core, I can run Nano Server, I can even run Microsoft SQL Server on my Docker, so that's pretty cool. Notice the sizes too. This is a little different from Linux containers. But it's all possible. But the reason it's possible is not a big trick, really. What I'm doing actually in the background is I'm running this little thing, the Runux Linux Docker host, which is a Windows Server Core VM, which I'm forwarding the Docker management interface out, and then I'm connecting to the Docker management interface. And this is why I'll talk about the Docker management interface in just a second. So come on, complete for me, yay. All right, so that's the trick. So I'm feeding off a different system and running it here in my Linux environment. Okay, so with that out, what's the catch? And the catch is simple. It's still in the works. Microsoft is still working on it. There are bugs all over the place. There's still unimplemented features. The networking is buggy, and unfortunately I had to spend like 2 days in and out debugging the network where it would die in the middle of a very intensive stream, and it was horrible. But I still have headaches about it. But so another thing is Nano server is headless. You can't run any GUI on Nano server. Windows Server Container doesn't have an RDP built into it, so you can't RDP into it. So what that means is you can't have that nice GUI Windows containers. What I showed you from Linux just a second ago, you can't have that on Windows. It's just not possible. So maybe one day when Microsoft actually goes into implementing the RDP into Windows containers, maybe then you can have your GUI from the Windows containers. And you also don't, there's no way to update Windows containers. And I go, well, wait, what? No update on Windows? So, yeah, containers are immutable. And the way that Microsoft wants you to do it is they want you to re-upload, rebase your image, rebuild your image. So every time you pull an image, you actually are building on the latest fix spec that they build in. So what it means to you, if you're running Windows containers, you have to rebuild your images. That's the only way you can get a Windows update on a Windows container. All right, moving on. So let's talk a little bit about security of the Windows containers, because that's Windows. You have to talk about security. And a couple of things. One is apparently, I have no idea why they did this, but when Docker ported their stuff to Windows, they rewrote it in .NET instead of Go. And what it means to you is that now you can look at the source code. Now you can reverse the source code and look at the Go. Because there's .NET, just like Java, you can look at the .NET code reversed from the byte level code. So one guy did it. He opened it up. He said, all right, cool, let's look at the Docker core DLL. He found this little thing that passed packets from the Docker control interface, and he said, it says serialize. I wonder what I can do with this. So what he did is he built a deserialization attack on the Docker.NET DLL, and he got himself to escalate the privileges from the normal Docker D into a Docker user with net authority system. So that's the thing. Just making you aware, that's not a horrible thing, but it is a thing. Another thing that people did with Windows containers, and this is really cool attack. I will walk you really quickly through this because I think it's cool, it's worth knowing about. It was demonstrated at Black Hat 17, and it relies on several critical Windows components. But basically what it is somebody, a developer, goes out to a malicious website, and the malicious website has JavaScript. And that JavaScript wants to target your Docker instance. And by default, just like you saw me here exposing that interface, developers do expose the internal interfaces out to their systems. And by default, it will be bound to 000, meaning to any interface. So Docker is listening on your machine on any interface for any action you can do with Docker. And what they do is that malicious JavaScript then reroutes back to the Docker daemon on your machine through little tricks with DNS rebinding. Microsoft has this LLVM thing for assigning DNS names, but you can trick it in essentially saying you go into pwn.something, and then that pwn now resolves to your local Docker daemon. So the JavaScript from the browser is now talking to the Docker daemon on your machine. And from that point on, you have full ownage because you can actually create new containers. They created new containers. They put a shell script into that container. That container actually, because you're running at root privileges, and I'll show it in a second too, that infected the Moby VM. Remember I talked about the VM running on Linux. So infected, made persistence. And so at that point in time, every time you spawn off another container on your machine, it was already rootkitted. So if you're interested, find out more about this. They go into a lot of details, but that's just a kind of cool thing that you can do with the containers. Okay, so another thing that I had to deal with is that I was working with very sensitive intellectual property. I was dealing with encrypted installers because that's sensitive IP. You don't want to get it out. I had to have a sensitive deployment. I had a special licensing protocol that I had to do. Basically, I had to protect my employer at the time. And I had to make it secure. Now, well, so just to explain to you what's going on here with secrets, and by the way, there's another conference talk going on about secrets at the same time, but let me show you something. So let's say I'm building a container and I want to look at storing secret information. And I build something like this. I look at my Docker file, and it's something like, I've got a secret here. Maybe I can store my secret in the environment variable. But if you look at Docker, you know that you shouldn't really be storing this. I can try to store it in the build arguments. I can copy my super secret file into and then delete that super secret file. Maybe that's good enough for me to build a Docker container and actually, get my secrets into the container without exposing them to the end user. Well, so I'm sure you guys heard about Docker history. If you haven't, you should. And the Docker history is this. Where do I have it? So I should probably build this. So I'm building it. So I'm doing this. And I'm going to do this. I'm going to add a build because I'm smart. I've heard about security. And I'm building a build argument to assign my secret password at the build time so I can save it and not have to give it out to the customer. So it builds. And then I do this. I just want to check how it built. I do a Docker history. I do my container. What did I mean? Secret. Come on, complete for me. I don't want to type. All right. And I see something really odd in this history. So instead, it kind of looks ugly, but I build this little tool called Docker Historian, and I do this, and it gives me, oh my gosh, it gave me back my Docker file. And it gave me with the secret here. And, well, thankfully the file is deleted, so it shouldn't have any files in that. But it also gave me this, like key2 secrets, so all your secrets are exposed. You can't save them in a Docker file. Well, moreover, actually, take a look at this. So here's my Docker historian for, let's see, what do I have? The SQL, my little Microsoft SQL file, SQL Express. What? Okay, so here's my secret. My Docker file. It's essentially reversing the Docker file back into what it was. So if you ever get an image and you want to find out how it was built, run this. You're going to get your Docker file back with all the details. Moreover, you'll actually see this part is what Docker did themselves. This is how they built the image that I built my Docker file from. So you can reverse all the way back. And just to show you, I don't have anything up my sleeve. Here's my Docker file for Microsoft SQL. So this is what I did, and this is from Docker. So this is it reversed. You see it looks a little bit different. Obviously, it's not the same syntax. But then this is what I got from. So if I ever want to rebuild Ubuntu like they did, I can just run this file. So that's easy. All right. So that was about history. Now, another thing is like, all right, what I do about the file. And there's Docker save. And I do Docker save. And I save my secret to dump. And let's see what's in that dump. And I go start my little tool. And it starts right here. Okay, I have the dump file, and I look in the dump file. I look in my dump file, and I look at what's going on. Sorry, oh, there it is. Okay, so I look in the dump file, and there's several layers in that dump file, and there's a JSON in that dump file that actually interesting too. You can look at all the details of the JSON file and see what's going on in there. You can see the secrets too if you wanted to. But what's more interesting is that Docker file has layers. And in one of the layers, I find the super secret file. And this is because that's what Docker does. It never deletes stuff. It actually creates layers. The file system is write on or create on write. So whatever you write something, it creates another layer. So your super secret file is still there. Don't worry about this. Okay. So that's about secrets, and that gave me a huge headache. I had to look at it, and it's like, oh my gosh, I was building Docker, and I built this. What do I do now? Well, turns out there are solutions, and the solutions are either squashing or multi-stage builds. I'm not going to go into details. Unfortunately, that's not supported on Windows, so it was a pretty bad move. Now, there are open source solutions like Docker Vault and others like HashiCorp and Kubernetes and Swarm. That was an overkill for me at the time. So what I did is I built a standalone Docker container to contain all the secrets, so during the build time, they can get the secrets from the standalone Docker container. But that's essentially the extent you have to go to actually build a secure and reasonable solution. And then last thing I had to do is, okay, now I have to have a standalone Linux container. So let's look at the Linux security. And the Linux security has gotten a lot of attention. Linux Docker container security got a lot of attention over the past years. So I'm not going to go again into details. If you're really interested in figuring out if they're secure, the short answer, yeah, they are secure. No talk goes about referencing just Frizzell and her container.af thing. Basically, it's proving that they are secure unless you do stupid stuff. And unfortunately, people do stupid stuff. But there's you can do protections against the DOS. You can there's capnet raw capability in Linux containers that in theory give you a man in the middle, but in practice nobody actually proved it. There's also now a set of tools that allows you to look into the application side of your container and defend from the application level your container. But there are tons of food guns, and food guns is something you pretty much do to yourself, and this is how you screw yourself over. So here's a typical scenario. If you ever run node inside of a Docker container, you'll probably encounter this. When you hit Control-C, the container doesn't terminate, and you do what? You Google, right? And the first thing that pops up is this guy from Docker thread saying, okay, if you can't terminate it, just add the --pid equals host, and you're good with it. No change to the code. And you're like, yay. Well, what this does is it exposes all the processes from your host to your Docker container. So whatever is running inside of your container can now look at the command lines on your poor host, and it's like, yay. So the actual answer is to add signal handling inside of your app. There are other food guns that people do to themselves, like the root thing. So let me show you the root thing. So never run containers root. You might have heard this, but here's the actual proof. So docker run remove and do interactive with the volume of / mounted to /r on your container and do all parting because it's small. And run this. So this is a Docker container. And notice I'm running it as myself, right? I'm user. I'm not doing sudo anything. But then I'm kicking off this container, and I do inside of that container, I do grep for root inside of /r. Remember, that's where I mounted. And etc and shadow. Whoa. So I basically got root on my machine without being root. And the reason it works is because the Docker D container is running as root, and I'm a part of the Docker group. So that last group, that essentially gives any container a run root privileges. So if you run root inside of your container, you're root on your host. That's it. There's no joking about it. So don't. Just don't. Okay, the other thing that people do, and I actually did it in front of you guys, and if you haven't noticed, exposing the socket. So socket is the way the Docker D communicates to yourself. So when I showed you my little trick with Windows, that's the socket. In Windows case, this is the TCP socket. In the Linux case, it's the actual socket. So when I'm exposing my socket, I'm exposing myself to that attack I just showed you earlier. And that's not just Windows, it's Linux too. If I can write to the socket, Windows Docker doesn't do any authentication. It'll just trust it. It's like, you can talk to me, all right, I understand. I'll run the container for you. And if you're running it as root too. So it's like, So if you do something, try not to do this Docker sock thing exposure. Sometimes you have to do it, and if you need to do it, talk to me how to work around it. But yeah, Windows is kind of like that. Just to show you again why not to expose your Docker socket. In 2018, the Docker had 18 backdoor images that were mining Monero. And it's a known thing, you know, Docker kind of warmed up to it and they killed the